Hello, my name is Aaron Addair, and I'm going to be talking about the brain basics today for my midterm in human growth. And this is the brain basics, and this is a picture of neural pathways. You see all the neurons here and going around from axon to axon. Right. So I'll start off talking about the lower brain and your brain stem, and it's right here, and it uh, uh, it's more of your basic functions. It has to do with your fight, flight, or freeze uh, kind of responses to stuff. It has to do with like very basic stuff like breathing, your appetite, your sleep cycle, and stuff like that. And then the next thing is talk about the midbrain or your limbic system. And the first thing is the amygdala, and it's mature at birth. It's your seat of emotion, and it has to do a lot with bonding. And I'll talk more about that in more slides. The more slides ahead, we'll get a little bit more into detail with it. And then your hippocampus is it's your memory saver. It's where your memories are stored at. And both of these, or both regions, handle the next 15 seconds of your life. So the next 15 seconds, that's what it is. Then there's your upper brain, your prefrontal cortex, and it maintains your attention. It controls impulses, problem solving, expression of your emotions, and it's not fully formed until age 25. And this is, well, the more slides into it, I'll get more into it. But your prefrontal cortex is right there, and I'm sorry I didn't talk about your hippocampus. Is right there towards like the middle part of your brain there, and then your prefrontal cortex is right here on the front part of it there. And it's not fully formed until 25, so mine's still not fully formed. So uh, we'll simplify it a little bit. Your amygdala is your guard dog. Your hippocampus is your memory saver. Like I said, it stores your memories. And then your prefrontal cortex is your wise leader, which is your that's where you learn a lot. At you deal with problems a lot better. You can solve a lot better at problem solving with it. And I'll talk more about it. I think the next this slide's better with it. So sorry about the setup here. I know it isn't great, but we have right here we have a sensory input, some kind of sense towards something or anything. Then it will go to your limbic system, and then it can go either one of two ways. It can either go to your guard dog, or you can get up into your memory saver and into your wise owl. And I'll explain that a little bit more. So what would happen is when you're at your guard dog, like the slide says right here, it says, I'm unsafe, and then obviously you would go into your fight, flight, or freeze senses because you feel unsafe, and your guard dog is on high alert. You're still in the amygdala, the brain towards the brainstem part of your brain when you're at this very I don't know the word I'm wanting to say here, but you're kind of very alert. Your guard dog is on high alert, and that's what you go into. You go into your fight, flight, or freeze, but you can also go the other way, and you can think, I'm safe. I've got all my necessities into it, and you can reach into your prefrontal cortex up here at your wise owl, and you can problem solve a lot better. You can control your emotions. You can express your emotions a lot better because you're in the prefrontal cortex, your wise owl. And Miss Smith explained it. She had a really good one. She was talking about a an argument with her husband, I think, and she was explaining how they was in this. I can't remember what she was talking about, some kind of argument, but she told him, I just need to take a break. I'm in my guard dog's on high alert. I'm at the lower part of my brain. Let's just take a minute or two here and try and come back in a minute, and hopefully she could be back into her prefrontal cortex to where she's not on this fight, flight, or freeze kind of thing, and she can obviously problem solve better. She can express her emotions to her husband a lot better, and she can do a lot more stuff a lot better. Uh, just because she's in the more complex part of the brain, her prefrontal cortex. And she said a lot of other stuff, but I really thought that really helped simplify it a lot better. So, I mean, this is kind of the same thing that she was talking about. Her story with that is, so you got your downstairs part of your brain, your brain stem and your amygdala down here, and then where you want to be at, well, yeah, you want to be there is your upstairs part of your brain, which is up here around the prefrontal cortex. Sorry, I can't. I know my hand got in the way there, but you're in your prefrontal cortex here, your upstairs part of your brain. And a lot of what we've talked about in human growth is getting kids from their downstairs part of the brain to get into their upstairs part of their brain, so they can obviously do a lot better. They can problem solve better. They're expressing their emotions a lot better, and they're just doing a lot more better than when they're, or other than being in their downstairs part of their brain and they're fight, flight, or freeze, and they're just their guard dog is constantly on high alert. And that's what this is trying to be. If we're in our downstairs part of the brain, we're trying to work our way up slowly to our upstairs part of our brain. And then this next one is trauma and the brain. This is this next couple slides here. So I looked at this slide a little earlier, and this is honestly kind of crazy. I think this is so we've got over here 2 PET scans of 2 different kids, and it says healthy brain and an abused brain, right? I don't know anything. Just an abused brain, I guess, is all I'd say. And so obviously what you can tell right away is this kid, the healthy brain, there's a lot of activity in the prefrontal cortex and right here at her temporal lobes, and she's in her upstairs part of the brain a whole lot more. But unlike this one, there's not as much activity going on in the prefrontal cortex, but there's more down here in like her brainstem, her amygdala and stuff. And her guard dog is constantly, obviously, on high alert. And it talks about it. The brain of a normal child shows regions of high red and low blue at birth only, primitive structures, blah blah blah. So this is a healthy child. Has all her necessities. Her that's also in another slide on or so to come. But she's got all the stuff that she needs to have the ability to learn and to do a lot of different stuff. So she's in her upstairs part of her brain a lot of times. Unlike the abused brain here, which is, I read it just a minute ago. Yeah. So a Romanian orphan, obviously that's right away. Institutionalized shortly after birth, shows of effects of extreme, just different stuff, just really an abused brain. She's had a lot of trauma into it, and you can see right away that she's constantly on her, or she's always, well, not always, I won't say, but you can definitely see that most of her activity is down here in her lower, she's like in the amygdala. She's in her lower part of her brain there. She's not in her upstairs, she's in her downstairs. And there was also other videos that we seen in Human Growth. There was one about a girl that got, she was also like, well, I guess, but she was like in an adoption thing, and she was, I forget, I think the parent bought her like a dress, and obviously because of trauma, something was wrong with the dress or something. I can't remember the video right off the top of my head, but she had some kind of traumatic kind of experience with the dress in her past life. So then when she seen that dress again, right away her guard dog got up on high alert, and she was in her downstairs part of her brain. And unlike the healthy brain, where it's in the upstairs part of the brain, she was in her lower part of the brain, and she was just, I think she went off and screamed at her and told her she hated her, and she was just all these built up emotions because her guard dog was on high alert, and that's just what she did. So this one is Maslow Before You Bloom, and basically what it is you've got down here your physiological needs, your well, like you know, you've slept enough, you've got the right nutrition, you've got all this. There we go. But you've got your nutrition and stuff like that, and then you keep on going up here. You go, you know, safety, security, and order. You feel safe. Your love and belonging. Your self-esteem, and then your self-actualization. And that's your hierarchy, or that's Maslow's hierarchy of needs. And you have to have all of these needs before you do your Bloom's taxonomy here, your learning. So let me just explain it real quick. Is you've got your ways of, well, not ways, but like your levels of learning, I guess you could call it. You know, you remember stuff, you understand, you can describe stuff, you apply stuff, you evaluate and analyze things, and then you can create, and that's just your levels of learning kind of thing. But before you can get to even the lowest level of Bloom's taxonomy here, you have to have all of your Maslow's stuff here. You have to have all of your needs all the way up. Your like you need your foundation, and that was a big thing I think we talked about too. Is, you know, we want to just kind of skip to this part or this part, these one top parts, so we can hurry and get to this. But unless we have the really good foundation right here, and what I really like about it is it's obviously in the triangle shape here, but I like it where it's the biggest here, down here at the bottom here. Sorry, my hand's covered it again. But it's like a good foundation for a house or something like that. You have to have these in order to get these higher parts of the hierarchy. This is your foundation, and you got to keep building on it, and then you can do the same thing with this. Is with your Blooms, as you can keep building up until you're at this very high level of learning. Obviously, create, but that pretty much sums that up. And then to end it off, we therefore need to stop punishing kids for their neurology. We don't need to punish them for what we don't know about them. And obviously, I think that sums it up. All right, thank you.